Module 1, Lesson 27, Solving Percent Problems. So we are into our percent some more today, and as we take a look at our learning targets, and I keep emphasizing this in each lesson, we don't have a learning target specifically for percents because percents are a form of ratio and rate. So we are looking at a fixed relationship, and we're looking at a per 100, so two values that are being compared, and the second one is a 100. It's a per 100. That's a percent. And of course, these are part to wholes with the 100 representing the whole. And as we reason and make comparisons, we're scaling ratios and rates up to b out of 100. So I can statements, I can find a percent when I am given a quantity. So if we say 5 out of 9, we can find a percent. We can find what percent 5 is of 9. I can find the whole when I am given a percent and the quantity the percent represents. So if 5 is 20%, what is the whole? And of course, we'd scale up multiplying by 5, scale up multiplying by 5, and we'd find out that the whole is 25. Okay. So for today's lesson, it's important that we are thinking about what are we looking for. And I love representing this with a tape diagram. We can be looking for the whole, the 100%, because these two things are equal. We could be looking for one of the parts. So right here we have a part, and that part could also be a percent. So we can find that maybe the whole is 25, and we could say that this part here is 5, and we could say that it is 20%. And of course over here we have a different part. This would be the 20, and it could be the 80%. So we need to think about the different parts that we're looking for. So for example, looking here, we're looking for 60% of 300. So on our tape diagram, the 300 is the whole, and it's the 100%. So I'm not looking for the whole in this problem. They already gave me the whole. And I am looking for 60%, so they've told me the percent that I'm looking for. But what they haven't told me is the value of the 60%. What is the 60% equal to? Which is the part. So I am looking for a part here. I am looking for 60% of 300. And of course, there are a variety of strategies that we could use for this. Probably one of the most straightforward is take the 60% and write it as a fraction and scale up to 300. And that would give me 180. So 180 is 60% of 300. Of course, I could go the other direction, which we have talked about. I've got 60%. I could scale all the way down as far as I could possibly go, so divide them by 10. And then divide by 2. And I've got 3/5, and now I'm down to this unit rate. And from there, I could scale all the way up to 180. And of course, a double number line would also work if you chose to do that. I'm not going to show this on every problem, but a quick review of some of these strategies. So I know that 300 is my 100%. It's my total. And I need 60%. So on my percent line, I need to go from 0 to 100%, and I need to make sure that I count the 60 as I go. And as I've discussed in other video and in class, we want to count by the largest possible units. So I would probably want to count by 20s to get from 0 to 100. So 20, 40, 60, 80, and 100. 20, 40, 60, 80, and 100. And I've taken the 300 and divided it into 1, 2, 3, 4, 5 parts. And 300 divided by 5 is 60, so I'm going to count by 60s. 60, 120, 180, 240, and 300. Now, it would be really easy for a student to have a misconception that because it said 60% right here, I have to count by 60s. No, 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 no. That is not why we counted by 60s. We counted by 60s because the 100% was equal to 300, and the 300 got divided into 5 pieces, and 300 divided by 5 is 60. And I can see that 180 is equal to 60%. All right, taking a look at the next one here. 60% of some number here is equal to 300. Well, thinking about my tape diagram here, they don't tell me what the total is. I know the total is going to be 100%, but I don't know its value. I don't know what it stands for. I do know that there is a 60%, and I do know that that 60% is going to be equal to 300. So I have the percent, the 60. I have the part, which is the 300, but I am missing the whole. I don't know what this total is. So I need to have a strategy here for figuring out what the whole is. So once again, probably one of the easier methods, I've got 60%, and I know that the 60% is going to be equal to 300. This 60% is equal to 300. So when I scale that 60% up, I will get 300. And the question is, what did I scale by? Well, multiplied by 5. How did I get 5? 300 divided by 60 is 5. So I know that they took this 60 and scaled it up by multiplying by 5, so I would multiply this by 5, and I would get a 500. So I would find out that the whole is 500. So that's one strategy that I could use. Now, another strategy with the double number line, which is kind of my favorite go-to for percents, really helping me see what's going on. I know that there's 100% out there, but I don't know what it goes with. I don't know what the 100% is. I do know that I have a 60%, and I know that that is equal to 300. Now I want to count from 0 to 100, and when I'm counting, I want to make sure that I count the 60, so I'll count by 20s. 20, 40, 60, 80, 100. And I can look at my double number line and see that this 300 has been divided into 3 parts. So I'm counting by 300 divided by 3. Each part is hundreds, so I'm counting by hundreds. 100, 200, 300. I've got a 400 here and a 500. So I can see that the whole is 500. All right, looking at the last one, and we've got 60 out of 300 is a percent. So thinking of my tape diagram here, I know that 100% is the total. It's the everything. And as I look at this problem, I see that I've got a 300 here for the total, because I'm looking for 60 of the 300. So 60 of 300. So I also know the part here. I've got 60 out of 300. But what I don't know is what percent goes with this 60. So I can see the whole is 300. I can see the part is 60, but what I can't see is the percent. So I'm searching for a percent here. $60 out of 300. So I've got a couple of options here for how I can think about this. Kind of following the trend. 60 out of 300, I can scale this down to be 100. So divide by 3. And I can divide this by 3. And I can have 20 out of 100, which is 20%. Another strategy, double number line. And I've got 60 out of 300, so on one line I've got my percents, and on the other I've got my numbers that I'm counting. And I've got 100%, and I know that 100% is equal to 300. And I know that somewhere out there is a 60. And I need to count on my number line from 0 to 300. And when I'm counting, I need to land on the 60 and on the 300. So one of my favorite things to say is, hey, can I divide 300 by 60? And the answer is yes. So I know I'm going to count by 60s. So in some ways, what you're looking for is the greatest common factor of these two numbers. And I know that's something we haven't worked on yet, but that's what we're looking for. So 60, 120, 180, 240, 300. And what has happened here, as I have done my counting, is I have divided that 100 into 1, 2, 3, 4, 5 parts. And 100 divided by 5 is 20s. So I know what I'm counting by on the percent line, and I see that 60 is equal to 20%. Now they ask this question here of how did your solving method differ with each problem? Well, there's kind of this pattern that emerges. On this first problem, we had 60 over 100, and we knew that the total was 300, and we were missing this number right here. We were missing what part of the 300? We were missing the part. And we did some scaling. On the second problem, we had 60% of some number is equal to 300. So we were missing this number. We were missing the whole. And on the third one, we have 60 out of 300, 60 of 300, and we are trying to get to the percent. And I'm going to rewrite that last one just a little bit. We are looking for the percent. I'll use the X for it. 100, the percent, the part of 100, and being equal to 60 out of 300. So as you look at these three different examples here, you can see that we're looking for three different numbers. We're looking for a percent, the part per 100. We're looking for the whole. And we're looking for the part, which corresponds with what we were doing on the side here, looking for parts, wholes, and percents. So when we're looking for the part, which was here, we're looking for a numerator. When we're looking for the whole, right here, we're looking for a denominator. And when we're finding the percent, we are looking for a numerator, but the denominator is 100. So there's a little pattern that kind of emerges as we look at this. All right, so we're going to do a little shopping today. So we're going to use some models, 10 by 10 grids, ratio tables, tape diagrams, double number lines to solve the following situation. So Priya's doing her back to school shopping, and she's got this table set up, and we need to find the missing values. We're going to round to the nearest penny, and we're going to find the total amount that Priya will spend on her outfit after she receives the discounts. So we've got shirt, pants, shoes, necklace, and sweater, and for each one of them we need to figure out, using the information that is given, a missing piece of information. And as we do this, we need to be thinking about parts, wholes, and percents, and we need to be thinking about the different strategies that we have to figure these things out. And it's important once again to remember that we are going to be rounding to the nearest penny, which is the nearest hundredth. All right, so we are looking at the shirt here, and as we look at the table for the shirt, we see we have the original price of $44. And what we're looking for is the amount of the discount. So in other words, they're taking 20% off the price, and the question is, that 25% is equal to how much money? So we're not finding the new price of the shirt, we're finding out how much they are going to subtract from $44. So we have a few different strategies we can use. And of course, one of my favorite go-to strategies is to do a double number line, but I'll show you that one second. I'll show you this other one first. So I have 25% of $44 is equal to an amount here. I have my percent, I have my whole, I am looking for a part. So I know that 100% is going to be equal to the $44, and I've got the 25%, but what I don't know is how much is that 25% worth. So I know that I have 25 hundredths, that's my 25%. You know what, I'm going to bring this up here, 25 hundredths. And I know that it's going to be equal to an amount of the $44. So that's going to be equal to my amount of $44. Now the question is, how can I scale this 100 to be equal to the amount of 44? That's a little bit ugly. That's a little bit messy to work with. So I'm going to look at this 25 hundredths here, and I'm going to think to myself, is there something I can do with this 25 hundredths to make it a little bit easier to work with? Now that 25 hundredths, I'm going to take and I'm going to get it down to the largest possible units. So maybe I can build from my largest possible unit up to the $44. So I know that both of these can be divided by 5, and that gives me 5/20ths. And then I can divide both of those by 5s, and that will give me 1/4. So now I have a 1/4 that I would like to scale up to a 44. Now that is doable. I couldn't really take the 25 hundredths and scale it easily down to 44. But I can take this 1/4 that the 25 hundredths is equal to, and I can say, hey, multiply times 11 and you have scaled up to 44. So multiply times 11 and I find out that the discount is $11. So that's an example of a time when it's very useful, very powerful, to be able to scale down to the largest possible units. So I can take 25% of the shirt, which is $44, and the 25% is $11, and I've got the amount of discount. Now, I know you guys get tired of me hearing me talk about double number lines, but really love these. The 100% is equal to the $44, and I'm looking for 25%, and so I go 0, 25, 50, 75, 100, and I can see that I took the 44 and divided it by 4, and I got 11. But I do like the other method where you're thinking, how can I get this down to largest possible units and use it? All right, so now we're taking a look at the pants. Now on the pants, it says there was a 30% discount, and the 30% discount is equal to $15. So I've got 30 hundredths, and I know that the 15% is equal to the $15, and I am looking for a whole amount here. So I need to think about the strategies that I have that would help me find that whole amount. Well, looking at scaling here, I see that the percent has scaled to 15. It has divided by 2. And that means this divides by 2, and that tells me that it's $50. So here's an opportunity where it was possible to quickly scale this percent discount into the part. Thinking about our chart here, I know that I've got a 30%, and I know that that 30% is equal to the 15. I know that the total is 100. I can divide this by 2, so I can divide this by 2. Except the 50 goes with the total down here. Now a double number line would absolutely, positively work for this problem. So I know that somewhere out there is a total for the price, and that's 100%. And I do know that there is a 30%, and that 30% is equal to $15. So I need to count, getting from 0 to 100, and when I'm counting, I need to land on the 30s. I need to count by tens this time. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So I can look at my double number line, and I can see that this 15 here has been divided into 3 parts. So each part will be equal to 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. And I can see that the original price of the pants was $50. All right, the shoes. The shoes had a 15% discount, and I can see that the 15% discount is equal to the $9. So thinking about this, I know I have 15%, which is 15 hundredths, and I know that that 15% is equal to $9, but I don't know what the total price was, the original amount. So I am looking for this right here. Now looking, is there an easy way for me to scale from 15 to 9? No, not really. I can't think of anything obvious that I could divide 15 by to get 9. So maybe I'll take this 15 here and I will scale it down and see if I can get largest possible units and then use those. So I can see that both of these are divisible by 5, and 15 divided by 5 is 3, and 100 divided by 5 is 20. So now I've got a 3/20ths that I know is equal to my 15 hundredths, and now I have something really easy to scale with. 3 times 3, 20 times 3, and I'll find out that the total price was, sorry, the original price was $60. So once again, there is a lot of power to be had in scaling down to the largest possible units, and then I can build up from there. Now, could I do this with a double number line? Of course I could. I know that there is a total price out there, and that is 100%. And I know that I have a 15%, and that it is equal to $9. And I need to count from 0 to 100, and I need to land on the 15. This is a time when the double number line may not be as efficient because I'm going to have to count by fives. I'm going to get to draw a lot of little lines. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95. Oof, spacing on my line was atrocious. So I'm going to find out that each one of these is 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. So I took the 100 and I have divided it into 20 parts. But I'm looking at the 9 now and saying this 9 has been divided into 3. 9 divided by 3 is 3, so 3, 6, 9. So each of these is 3, and if I've got 23s, I've got $60, which is what we found out by scaling. So there are times when, as nice as the double number line is, there are more efficient methods. All right, so now I am looking for a 10% discount. I am looking for 10 hundredths, and I know that the original price was $20. It was the whole. Now I kind of like this one because it's really easy to scale from 100 to 20. I'm going to divide by 5, and I'm going to find $2. Quick and easy. Love that one. By the way, 10% discounts are totally awesome because a 10% discount means you divide by 10. So take this, divide by 10, and there is the amount of your discount. So I really enjoy 10% discounts. They're easy to calculate in my head. All right, and the sweater. Here we go, the sweater. I know that there is a 20% discount, so there's my 20%. And I know that the 20% is equal to $7. So this 20% is the same as the 7. And I am looking for an original price. And I am looking and saying, oh my goodness, there is no easy way that I can think of to scale from 20 down to $7. Not very easy. Maybe I can do some largest possible units. So I can take this 20 hundredths, and I've done enough work now that I know that both of these can be divided by 20. I've done this enough times. So I'll scale them down by 20, and I will have 1/5. So I can replace this 20 hundredths with the 1/5 equivalent, and now I'm looking and saying, man, that's easy. I'm going to multiply times 7, and I'm going to get 35 as the original price. Now, could I do this on a double number line? Of course I could. So I know that there's an original price out there that is 100%. I know there is a 20% discount, and I know that that is equal to 7. So I need to count from 0 to 100, and I need to land on the 20, 20, 40, 60, 80, 100. And when I do that, I can see that I'm just going to keep counting by 7s. So I've got 7, 14, 21, 28, and 35. All right, so now we're going to calculate what was the sale price. We had the original price, we had the amount of the discount, and now we're asking ourselves, what is the sale price of each item? Well, if I have a tape diagram here, I can have the original price as a total, and I can have the amount of the discount as a part, and then the sale price is the other part. And this should look an awful lot like, I think they call them math mountains and number bonds. So I should be able to take 44 minus 11 and get 33, and 50 minus 15 and get 35, and 60 minus 9 and get 51, and 20 minus 2 and get 18, and 35 minus 7 and get 28. So now I've got the sales price of each of the items. And here we've got the question of, okay, so what is the total original price? So before the discounts, how much was Priya going to spend? Well, that would mean we need to total its numbers up. And we've got 44 and 50 to make 94, and we've got 60 and 20 to make 80, and then we've got 35, 17 and 3. She was going to spend $209 originally. But after all of the discounts, which we have oh so carefully calculated, if we total these up, we can find out how much she's paying on sale. 33 and 35 would be 68, and 51 and 18 makes 69, and 28. 8 plus 9 is 17, and 8 makes 25. 6 and 6 is 12, and 4 makes 16. So the sale price, the total sale price, is $165. And we can use this information then to find out the total discount. I've got 209 minus $165 and find out that she saved $44. Now, I want to be just a little bit sneaky here, and I want to say, about what percent overall did she save? So the total outfit was originally $209. So that was the original total. And she has saved $44. And I would like to know, what percent is that? What percent did she save overall? So really what I'm asking here is 44 is what percent of 209? Now there are a few different ways that I could do this, but I'm going to go with one that we haven't so much looked at. I'm going to look and say 44 of 209. That looks like a division problem to me. So I've got 44 divided by 209. And I'm going to break out a calculator on this for the sake of sanity. 44 divided by 209. And I am going to get a big, long number here. But once again, kind of for the sake of sanity, I'm going to look at this part right here. It is 21 hundredths. She saved overall 21%. That was the total discount by the time she puts it all together. Now I know that this is something that we haven't so much looked at in class, and that's fine. Think of it as just a little bit of thinking here that you can use. Ah, shucks. I guess I was one slide off here because it says what is the percent discount for the complete outfit, and we just figured that out as being 21%. All right, so in class we would have a discussion and share how you solved the problem and what methods worked well for you. Well, there were two methods that I really keyed in on today. One was the double number lines, a nice graphical representation, something you can really see what's happening. The other was scaling. And sometimes that scaling, let's put something a little bit easier to work with here. Sometimes that scaling involved taking this all the way down to the largest possible units. So I would take the 20 hundredths and I would divide them both by 20 and find out that they were equivalent to 1/5. And then I would scale up to the 15 by multiplying by 3. So that was one method, was to scale all the way down to the largest possible unit and then build back up. And then of course we had times where it was nice and easy. And we could just scale directly. We just knew we had to multiply by 3. 300. All right, so lesson summary. Percent problems include the part, whole, and percent. When one of these values is missing, we can use tables, diagrams, and models to solve for the missing number. So the first thing we have to do when we have a percent problem is ask, what am I missing here? Am I missing the percent? Am I missing the part? Am I missing the whole? And then I need to think about the strategies that I have to help me figure that out. And that comes clear back to where the lesson started. Find the lesson slide here. Back right up here. Right here. Ooh. It's going to fight me today. Clear back here where we started out, we were identifying what were we missing, and we set all of those up in the same basic form. 60%, and we knew that 300 was the whole, and we were looking for this. And we had 60%, and we knew that the 60% was equal to the 300, and we were missing the whole. So here was a part missing, here was a whole missing, and we were looking for a percent, and we knew that it was equal to 60 out of 300. So clear back at the start of the lesson, we were kind of noticing this pattern here. I guess I want to draw a connection here. This 100% is equal to the total, so I put these on the same line. This 60% is equal to 300, so I put them in the same spot. They're both in the numerators. This percent is equal to 60, so I put them both in the numerators together. The wholes are in the denominator together. All right, skip ahead. Oop, come back. Let me get rid of the ink layer, I guess. There we go. Hey, now it's going to work. So we're figuring out what is the value that we're missing, and then we're applying our strategies to be successful. So hopefully you're feeling very confident I can find a percent when I am given a quantity. So 30% of a number. I can find the whole when I'm given a percent. So 8 is 20%. What is the whole? Looking at our learning targets here, using that fixed relationship, that per 100, and we took that per 100 and we were able to make comparisons and predictions. So, okay, what if I divide both of these by 20 and scale down to 1/5? First thing I need to know is that these two things are equivalent and that I can then use this to solve percent problems. And of course we played with part to whole ratios because what we're working on is percents. So that concludes Module 1, Lesson 27. If you've got any questions, make sure you talk to your teacher and make sure you complete your problem set.